This is an Esp8266 development board with a built-in relay and a DC to DC step-down converter. It's connected to my laptop through a USB to serial converter with its TXRX and ground pins connected to the header pins on the board. I'm trying to upload some code which I made for a different Esp8266 project to test if the hardware works or not. To upload any code to this board, it has to be put in flash mode by connecting its GPIO pin to the ground pin using a jumper wire, and then the code upload is successful. Otherwise, the laptop will fail to communicate with the board and it will show an error in the Arduino IDE. Fantastic! Now after the upload is successful, the jumper wire has to be removed and the board has to be reset so it can run the new code. Now, according to the new code, the ESP will first connect to my Wi-Fi router, then it will activate its own Wi-Fi hotspot, and it will work as a Wi-Fi extender too. Then I connected this analog capacitive soil moisture sensor to the ADC pin of the Esp8266 and it is showing the analog read values in the serial monitor. At first the ESP was showing 1024 reading consistently and it was not changing, but then I added a 10 kilo ohm resistor between the ADC pin and the ground pin and the cunt started working. And surprisingly, it's very accurate. When I dip the sensor in water, depending on how deep it is in the water, the values change and they are very consistent and repeatable. Then I spent about 4 to 5 hours testing its different pin functions because the built-in relay is connected to its GPIO 5 pin and it was acting strangely at boot and at runtime it was not consistently working, so I had to use a jumper wire to connect the relay pin on the board to the GPIO 13 pin. And we can see that it is working. Now, when the water level goes down, the relay is turned off, and then when the water tank will be refilled, the relay turns back on, and it will turn on the humidifier pump. That's right, cunts. I made a smart Wi-Fi switch which turns on and off a humidifier pump using data from a water level sensor automatically, and in addition to this, it connects to the Wi-Fi router and turns on its access point to work as a Wi-Fi extender. Then it serves a web page with buttons on it for manual control on both IP addresses. It also connects to the Home Assistant server through MQTT protocol and sends sensor data and receives switching commands. That would be the end of part 1 of this project. Thank you for watching. Please like and follow. You always do this. What's wrong with you? I was in the middle of recording the video and you ruined it. Now those 2 people who watch my videos are going to be disappointed.